Okay, so there's a couple different ways we can measure the weirdness of the shapes, I guess, is the way to say it. Because you both said, hey, in the district where 6 Orange was winning, you had some unusual shapes.
Yeah.
So they give 1, 2, 3, 4, 5 different measures, and we're gonna focus on the first 3, just because we're not trying to do the entire exercise.
Okay.
But skew measure, W divided by L, where W is the district's shorter dimension, length or width, and L is the larger one. So you just take width divided by length. So can you bring your picture over here?
Alright.
And just pick
Like,
any district, doesn't matter what it was, just pick one.
how would width like work for this district?
Okay, good, that's what I want to talk about. So we're going to look at this district here, and this is actually in your 4-win one, and
Yeah.
it's a pretty unusual shape. What would you say the width of this district is?
Like, either you could say, I mean, I'd probably say that like the distance, the total distance sort of up you go from here. So I mean, I'd say it's 5.
Okay, so the top to the bottom is 1, 2, 3, 4, 5, and how far is it across?
Also 5.
Also 5, okay. So this one, the width and length were the same, so let's just pick another one. Let's pick this one.
Alright. So here you can say the width is 2.
Uh-huh.
And the length is 1, 2, 3, 4, 5, 6, 7.
Okay, very good. And can you just make sure you understand that? What is the width and length of this region here, would you say?
So we've got the width. Width is 5, length is 3.
Okay, very good. So we're just going to do width over length for the regions. That's one way to do it, width divided by length. The next one, that's called the skew measure. The next one is isoparametric measure, 16A over P squared. Woo. Where A is the district's area and P is the perimeter. Okay?
Well, the areas for all of these are going to be 10.
Ah, all right, great. Good. That's a good thing to notice.
So all the tops are going to be 160.
Uh-huh.
So
And I guess,
You just have to count the perimeter.
yeah.
So what's going to happen? What sort of shape is going to have a small perimeter?
like a square.
Square is going to have a small perimeter.
This
All right.
and a larger, a more elongated shape like this will have a larger perimeter.
Okay. Can we get the perimeter of this shape here real quick?
So we've got 4, 6, 7, 8, 9, 12, 13, 14, and then 19, 20.
Okay, 20.
20 squared is 400.
Okay, so that's 20. And what's the perimeter of this almost square-like shape?
3, 7, 8, 9, and 14.
14. So you can see the ones that were squares do indeed have smaller perimeters than
Yeah.
that. Okay, good. So that's isoparametric, and then square, I'm not sure how to say that, Rioch measure? Area divided by S, where A is the district's area, and S is the area of the smallest square containing the district. Okay, bring our shapes back. All right, so pick a district.
Like this long one here.
Okay, what is the smallest square containing that district?
It's a 1 by 1. Oh, the smallest square containing it.
Yeah, the smallest
Oh.
square containing that
It's
district.
a 9 by 9.
A 9 by 9.
Is it with integer side length? Because like with the 10 by 10, you could like fit it diagonally.
Yeah, let's do it with integer side, or have the square going
Yeah, on an edge.
on an edge. Yeah, so you're right. Maybe there could be some clever way to rotate a square and make it cover it, but let's just do it on the edges,
Okay.
so we don't have to worry about that complication. So what I want you to do is I want you to pick 3 shapes from each of your districts. So each of you pick 3 shapes from here, 3 shapes from here.
Okay.
And compute the 3 different statistics.
Okay.
Okay, so you're going to each do 6 statistics total. Sorry, 6 districts total, 3 statistics. Each of you are going to do 18 calculations.
Okay.
All right, do you want to do them? You want to use a calculator?
Sure.
All right.
Okay. All right, so go off and do that, and then we'll talk about it.